In this video, we're going to solve a particular problem which appeared in JEE ADVANCE 2020. Here, it is given that if R to R is a real valued function fx, which is defined as x cubed minus x squared plus x minus 1 sine x, and there are an arbitrary function g. It is given that there are a function f gx which is defined as the product of the two functions. Now we have to test which option is correct. So again, in this particular problem, we have to test option wise, right? We cannot achieve the options, right, by analyzing the problem. It's very difficult. So that's why we go ahead and discuss it by option wise. Let's go ahead. In this particular problem, right, we need to find the differentiability of the function fg, right? So that's why we first try to find the using the definition of fgx equal to fxgx. Can we identify or try to find out the derivative, right? Let's go ahead. So first we consider the function f, and it says that it is a continuous and differentiable function for all x belongs to R. Now why? Because see that x cube, x squared, x minus 1 sine x all are undefined for all values of x. So that's why it is continuous, obviously, right? And as it is a continuous, we cannot say it's differentiable, but we can say that by normal understanding of differentiation, right? X cube, x square, x minus 1 sine x all are a differentiable function, right? It is all known, right? So that's why we are not tested for differentiability. Otherwise, we need to go ahead with the test. Okay, let's go ahead. So here we consider a function hx which is equal to fgx, basically, which is equal to fx and gx, right? Now our aim is to calculate f dash of h dash of x. So we apply the first principle of derivative to calculate the f dash h, right? So basically, for first principle of derivative, we generally say that f dash x is equal to limit h tends to 0 if x plus h minus fx divided by h. Also, we can say that, right, this h, what is h? H is actually means that if I trying to approach towards the point A, right, so f dash a will be equal to f a plus h, f a divided by h, right? Now, what is h? H means that if this is x and we are trying to approach towards the point A, right, from left, right, whatever, and this h tends to 0. So therefore, this is equivalent to fx minus fa divided by x minus a, where we have a limit x tends to a. So a plus a minus, defining that it is approach towards the left or from the right. Okay, that's it. So use that definition, not the general well-known definitions, right? Though, yeah, go ahead. So here, let's go ahead. So here we try to apply, use that h dash 1 is equal to x tends to 1 hx minus h1 divided by x minus 1. Okay. Now what is h1? Using the definition that it will be fx gx, it will be equal to f1 minus g1, f1 into g1 minus f1 g1. Okay, that's it. Now what do we do? Now see that f1 is well known, right? So let's calculate the f1 by substituting 1 in the place of x, right? So it will be 1 minus 1, 0, and x minus 1 have a factor, so it's 0 again, right? So therefore, we say that f1 equal to 0. So therefore, the limit will be converted to fx gx divided by x minus 1, because this term will be omitted, right? Because the value of numerical values of f1. Now, here we use a small tricks. Okay, notice that, right? As f1 equal to 0, so therefore this term fx, right, can be written as fx minus 0. It will doesn't change that function, and this 0 will be now replaced by fx minus f1, right? And we have multiplied by gx, right, which doesn't have any problem then. So let's rewrite that, and that's the tricks in this particular problem. Now notice, we know that the limit can be separated, right? So therefore we separate the limit as limit extends to 1 fx minus f1 divided by x minus 1 multiplied by the same limit into operating on the function gx. Now, if we recall that first principle of the derivative again, right, we can easily notice that the first limit, right, will be equivalent to f dash of 1, right? That's very simple. And we can say that f dash 1 is exists because the function fx is continuous and differentiable for all x, right? So therefore, h dash 1, we can rewrite it as f dash 1 and limit extends to 1 gx. So that's the calculation basically required before going to analyze all the options, right? Let's go ahead. For option A. Now, what is the option A? For option A, we understand it is given that g is a continuous function at x equal to 1. Now, as g is a continuous function, what is the definition of a continuity? Continuation definition of any function says that the left limit at 1 minus gx, which is equal to limit x tends to 1 plus gx, which will be definitely equal to the function value at 1. This is the definition of continuity. And the first two, if it is equal, right? So therefore, it is obvious that limit x tends to 1 gx exists, and that must be equal to g1. So therefore, we directly write thus limit x tends to 1 gx equal to g1 exists and finite. Now recall that h dash 1 definition here. So here f dash 1 is exist, and by the gx is continuous, right? So therefore that gx limit extends to 1 is also exist. So therefore we can conclude that therefore h dash 1 will be equal to f dash 1 multiplied by g1, and f dash 1 g1 both are finite. So therefore h dash 1 will be exist. That's 100% sure. So therefore we conclude that, right, that the function h, which is fg here, will be differentiable at x equal to 1, and hence option A is definitely be the correct answer or the correct option. Let's go ahead and put our concentration on option number B now. Notice that for option B, it says fg, that is h, is a differentiable at x equal to 1. Now we have to put a comment that g is continuous, yes or no, at that particular point. So here h is a differentiable function. So that means h dash 1 is exist. Now, as h dash 1 is exist, so therefore we can say that from that given obtained relationship, whatever we obtained earlier, right, that h dash 1 is equal to f dash 1 and limit extends to 1 gx, right, which imply the particular limit gx at x equal to 1 will be f dash 1 h dash 1 by f dash 1. Okay, that's it. Now here notice that by our analysis the denominator and numerator of the fraction both exist, but there are no such condition available in this problem, so that we can say that, right, this is equal to g1. There are no such condition, right? So therefore we not able to say that it's a continuous function. It may not continuous, right? So that information is not available. So therefore we say that as it is not true for all cases, one or two cases, yeah, it's possible. So that's why we'll say that if fg is differentiable, then g is continuous, it may not true. So that's why the option B is not necessarily correct, and that's why we don't select that option B as a correct option. That's it. Let's go ahead for option C now. For option C, it says that gx is differentiable. Okay, so it is given gx is differentiable, and we saw that differentiability is imply the continuity. Now, as the differentiability imply the continuity, so therefore we'll say that gx is definitely continuous at x equal to 1. Now notice that we already proved in option number A that if gx is continuous, fg is differentiable. So this g is differentiable can be replaced by g is continuous and fg is differentiable. So therefore, by the virtue of option A, we can easily say that option C is correct. So therefore, option C is correct in this particular case. Let's go ahead for the last option. Here it is says fg is differentiable. Now, if fg is differentiable at x equal to 1, we need to find that is g is differentiable. Notice that fg is differentiable. So therefore, by the virtue of option B, right? By the virtue of the option B here, right? It says that G is continuous, but that option is false. We already select and decided that. So therefore, Gx is not necessarily continuous. And if a function is not continuous, it cannot be differentiable. So therefore, we will say that G is not necessarily differentiable. So that's why option D is also wrong in particular problem. That's why for this particular problem which appeared in JEE Advanced 2020, we have two options correct, option A and option C. And that's it. Hope you understood the problem. Thank you.